Everyone, this is Rishi George and this is my Java lab experiment number 8 that is about multi-threading. And this is my question that we have to create they have given a situation that an aeroplane always needs to check whether the airport to see that if it has an available runway before it is able to take off or land. So we have to simulate this situation using multi-threading. So we'll see the code for that. Now here I have created a class named plane and I have imported the package of dot random for all those threads. Like here I have created the class and I've inherited this class from the main class thread, and I've created the class objects like r1, r2, r3, r4 objects, and then I have initialized two variables of integer type, that is id and tag, for the plane id and to see that if tag is to check whether the runway is free or not. And then I've created a boolean variable I and I've initialized it to false. Then I have created a constructor for the plane class, as you can see, with the int arguments passed as the int id, the four runways, and I have initialized this runways like this id dot id, so that initialization process, so that when we pass an object it receives and then goes to r1, r2, and r3. Then as we know that to run a thread, from to change its state from the start mode to run mode, we have to use this run method. So inside this run method we have an if else condition, nested if condition. Like inside this if we are having that if I is equals to false, that this I is already false, then we have if r1 dot available is equals to true, then I is equals to r1 dot landing id. Now here we are seeing that if r1 dot available is true, then inside that we are going to the boolean value I, that is already false, is equals to r1 dot landing. And landing, you can see that it's a function that has been called here in this another class, that is runway. And here also we have declared some variables like int id and log l, and again we have a boolean variable available is equals to true that we have initialized. And then we have the constructor for this class also, runway, int id, and this id dot id, the same initialization process. Here a new thing we can see is the reentrant lock. This is basically used to check whether the thread that we are giving passing, it until it is done with its job, it should be staying there. So this function is used for that, so that when it completes its job the thread can come out, only then another thread can go inside. So the landing function, as you saw, the landing function has been called through this object r1 that we pass here, will be received here. Like it will go here and it will show that landing boolean I, and if I is equals to l dot trilog I, we have already initialized there as false, is equals to l dot trilog, l is the log variable. Like if it is trilog, also checks the same thing as reentrant log to check whether the thread is empty or another thread can enter or not. And if I is equals to true, then available is equals to false. That means if it is true, that is already there is any thread, so it is not available, so it will show the uh, it will show as false. Then we can show that system dot out println plain plus idp, the object variable, is landing on runway, the id of the runway, and we can return the value of the I, that is if it is true or false. Same thing has been done with other runways also, like runway 2 and runway 3. We are calling the object, we are calling the function landing, and we are checking if it is filled or empty. And then we are giving the sleep, we are invoking the sleep method for the thread to sleep. And then we have another condition, like if tag is equals to 1 and I is equals to true. If this condition is true, that is in this we have initialized tag is equals to 1 here. So if it goes under this condition, like when the r1, we are checking for the r1, so like when the r1 landing uh, in the when the plane lands in the r1 runway 1, so it checks whether it is true or false. So if it is empty, we can land. And for takeoff also we have to check whether it is empty or not. So if is equals to 1, but it is already landed, and I is equals to 2, then r1 dot takeoff. So for takeoff also we have created the same object function. Like here you can see that for takeoff int idp system dot println plain plus IDP is going to take off from runway ID, and available we have given is equal to true, and L dot unlock to show that the thread is there, it can come out and another thread can go and come. For that method we are using this. So tag is equals to 2 is equals to 1 and I is equals to 2, r1 dot takeoff, and ID we are passing there, and that will be received here. Then the same has been done with runway 2 and 3, and for the fourth also, the runway 4. Here also there was a runway 4. And we are checking the conditions. If it is false, we cannot land from there, but if it is true that the runway is empty, we can take off there. Then we are invoking the sleep method. That is, as we here invoke the sleep method, we can see that inside the sleep method we have the try and catch block, that is thread dot sleep new random next int 8 star 800 for the time duration, and we are catching this exception in the catch. So here we can see the output. So when we put, we can see that plane 1 is landing on runway 1, plane 2 is landing on runway 3, 0 and 2, these random numbers. As we know that in multi-threading, these numbers are, the number of the thread are generated randomly every time it changes, and as soon as it lands, then it moves, and then we can take off from any of the runway, like it lands on 1 and then take off from 1, plane 2 lands on 3 and it take off from 3, plane 0 also lands on 0, and we can see the same output for this. So that was all about multi-threading. Thank you.